One. Hello to you. Good morning, good afternoon, good evening, wherever you are, depending on what time you are seeing this. I hope you are doing well. My name is Dr. Nancy Miles Bafojimfi. I'm one of the lecturers teaching you critical thinking and practical reasoning. And I'm also the coordinator currently for the 2022 academic year, first semester. Okay. So some of the information you have, even as part of this content, will be also coming from the place of the coordinator. And I would wish that students will take particular attention to them. Be guided though, if you are studying this content as a student in later years, because this content will be a public document. And so you may be able to access it if you were a student in later years beyond 2022, or even second semester of 2022, then you will be minded not to think that the administrative instructions regarding interim assessment, stuff like that, also apply to you. That wouldn't be. But the content proper, hopefully, will still be the same. Okay. So the topic that Unit 7 is engaging is the question of inductive reasoning in the sciences and everyday life. When we talk of the sciences, we mean the empirical sciences now. We could have the sciences and we would be thinking of deductive studies like mathematics, logic. But here we reference sciences to mean empirical sciences, the studies that depend on observation, gathering of data via the senses to do their work. Recall your discussions in Unit 5, the various senses of the word law, where you talked about normative and empirical, and how you distinguish empirical laws as predictions that could fail from normative laws as prescriptions that must be obeyed. Recall that because it would also be represented in your interim assessment, okay? So this unit is building on everything you've done from units 1, 2, 3, 5, 6, and now you are at 7. I didn't mention unit 4 because the content is not examinable. We are not examining you on the unit 4 content in your required textbook. The same applies to unit 8. Very interesting content there, but you won't be examined on them so that you have a relatively more manageable content to cover. But you could read it for understanding. I'm talking about unit 8, which discusses some type of inductive argument, like argument based on sampling, argument based on analogy. They are all instances of inductive argument, okay? So what? So this content plus the previous one from unit 6, given by the supervisor for that unit, plus the earlier discussions and content you've had in this course will all come together to constitute the exam questions for interim assessment. Okay, so interim assessment will cover units 1, 2, 3, 5, 6, and 7. You would all meet on campus at the time that is given by academic affairs in the 8th week. Sometime in the 8th week. We are now currently ending the 4th week. So the week coming begins the 5th week. You see that you start your 5th week, and then in the 8th week, hopefully we will have some certification on dates and venues and what have you. But the interim assessment for this specific semester I'm addressing will be done on site using university computers. I am speaking to main campus critical thinking students of the first semester of 2022. I didn't mention City Campus or distance education or any of our affiliates. So you may come by the recordings coming from the supervisors of these units, the various lectures. Do not transfer the administrative instructions onto others without guidance, so you don't stress them unnecessarily. This is for main campus students. Thank you very much. So the final exam also will now include the units 9 and 10. Okay, so interim assessment 1, 2, 3, 5, 6, 7. How many questions? You would answer approximately 30 questions in an hour. Okay, in 1 hour. There will be short answers, some multiple choice questions, okay, that you are able to do within an hour. No qualms at all about that. Okay, then you prepare also for the final exam, which will also be 50%, and it will have the same feature. So it is the 20% you are currently doing that will require you to write so much, since that one is offsite. And there again, I want to also quickly say that if for some reason you came in late, or you had legitimate issues that are, you can investigate that quickly and then clarify. Then you will have an opportunity at a makeup. So let all stresses go down and focus on the content proper. We'll give you the opportunity to take your missed assessments, even if it means opening new ones, not just repeating the previous. Well done. So we can move on quickly to substantive content, inductive reasoning in the sciences and everyday life. Now, the outline is brief. Basic principles of inductive reasoning. You should know that by the time we finish this brief. You should be able to distinguish verifiable statements from confirmable ones. Take note of the language. It's not just the content, but the language is very important. When we say we have verified a statement, it's not the same as saying you have confirmed it. So we want you to take note, even as empirical student, okay? Empirical science student. Then you should know one type of what? Induction. You learned some types of deduction previously in Unit 6. You learned modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. You even went further to look at some patterns that deviate from these valid patterns, okay? Induction also has types, and you'll see shortly, but the Unit 7 will focus, will emphasize, will stress a specific type of inductive reasoning, which is labeled as what? Enumerative induction. Then it will lead us to an understanding of law-like and statistical hypotheses and how much we are confident in findings like these based on what the evidence proffered. So you will see empirical content, predictive power, pseudo-scientific statement. These are all concepts that revolve around the concept of verifiability and confirmability and how we arrived at that conclusion. So basically, not so much, but yet intricacies are many, and we are trusting God to give us grace to make these concepts very explicit to you, to guide and aid your reading of the required content. I would want students to have a direct connection with the text, so that the lecture that you receive from all the various lecturers will only be as a guide, but you must have some contact with the textbook so you can get clarity. And the textbook, like I've said in previous discussions with my groups, I tell them the textbook is the constant in all these studying. Okay, our lecture slides and our contributions are variables. They vary because we are presenting content in a way that we want to make it explicit to you. So you see that there'll be variations here and there, which are not wrong, which are not different, which are not distinct, but they carry the person delivering the content along. So you see the person in the content. Sometimes if you don't connect easily with the person, then some of the content may be a little bit far-fetched for you. But then the specific fixed content, constant in all this is a textbook, what it is saying. So have some connection with it. Ask a friend a copy so that you can study along, share with a friend, buy your own, what have you, the point is not really about coming to buy it per se, because we don't even have much left. You may have to try some other places. The printed versions and it's the university's textbook. So as and when the university produces, you can have some. But my point is, have contact with the textbook. You don't do chew, pour, pass and forget. You see, you read it, the slide, the videos. You want slide, then you come in. You will not do well if you have that posture. And so we want to be minded. Okay, so how did we contrast induction and deduction? This is a recall. Remember it. We said for deduction, the conditions that make the premises true require that the conclusion must also be true, else you create a contradiction. Okay, that's deduction. So if the premises of a deductive argument, a good deductive argument at that, is true, then it requires that the conclusion must also be true, else you create a contradiction. That is not the case for inductive reasoning. When you reason inductively, it is possible for your premises to be true and your conclusion false, and yet no contradiction will be created. There will be no tension. We won't have a problem with our language use. Okay? Even if we accepted the evidence the person proffered as true, we will still have room. We can still decide to reject the very conclusion that that evidence produces. And there won't be any tension. He was the last person who left the room, therefore he stole the laptop. Well, yes, we can accept that he was the last person who left the room. But does it necessarily mean he stole the laptop? Well, not necessarily. The owner of the laptop could have stolen it himself. The person who pointed out who was the last person could be the thief. So even when we agree that, okay, let us take it that your premises were true, your evidence that you are proffering is true, we are still not necessarily required to accept the conclusion we are drawing from that. Then that reasoning, that argument you gave us was only an induced one. Now, depending on the degree of truth of those premises you offered, we may think of your argument, that is that inductive argument, as what? Probably true, highly probable. Okay, the degree of certainty may be high. When I say degree of certainty, then you watch. I don't mean that the argument is certain. So then let's not use that language so students can get clarity. The degree of truth, so probability. Chances are that what you are saying is true. Is true, but it doesn't mean I have proven it with certainty to be true. That doesn't happen in inductive argument. It happens in deduction, where the concern is only with what patterns and forms and structures, not with content proper. Okay, so think of an inductive argument like most Ghanaians like pineapples. These are from your textbook. Nancy is a Ghanaian, so I believe she likes pineapple. I said 80% of Ghanaians like pineapple, and Nancy is a Ghanaian. So the chances, the likelihood, take note of the highlighted words, the likelihood, the chances, the probability to believe that Nancy will also like pineapple is high. It's a probability matter, it's a degree matter, but it does not mean necessarily that even from your premises, we should accept that Nancy necessarily likes pineapple, because she could be part of the 20%, that few group of people from your own data, you see, who do not like pineapple. Therefore, the reasoning behind this is a matter of what? Degree of likelihood. But if I said 80%, there is a strong evidence I have offered. You see that? So we'll say that this inductive argument is a strong one. We don't describe inductive argument as valid or invalid. Validity doesn't apply to, okay, let me say it well, validity, that it is a valid argument. You can't say that about any inductive argument. We say that about deductive argument. It's deductive argument that can be valid, but inductive argument cannot be valid. They are necessarily what? Invalid already. Because I've said it and I'm repeating and I will ask you, that is why I'm saying it over and over again. I'm saying that because for inductive argument, even if all the premises, evidence, were assumed to be true, it would still not necessarily lead to the what? Certainty of that conclusion also being true. That's the nature of inductive argument. It comes with its sickness already. However, you can have a certain high degree of likelihood if the claim you are making is having what? a lot of confirmations, and we are getting to that shortly. If you have been able to confirm it with several instances that corroborate it, then we can say it is highly confirmed. The degree of confirmation is very high, but it doesn't still mean that it is a certainty. Okay, that means the conclusion may be false even if it is assumed that the premises are true and no contradiction will be created. That's clearly the difference between induction and deduction. And if you got that, then you will see why we would say that confirmation is not proof. Look on your screen. When we confirm, we haven't proven. We may have several instances. Yeah, she's a woman, she cheated. Mansa, she's a woman, she cheated. Adwa, she's a woman, she cheated. You see, and you have all those, and you are listing them and telling them, see on the screen now. Okay, I dated Amma and she cheated. I dated Ya and she also cheated. I dated Mansa, she cheated. I dated Afi, Zainab, and they were all women and they cheated. So see the conclusion. So believe me when I tell you that all women are cheats. If I argue this way, what I am doing is giving you several reasons, evidence, premises to support my claim that all women are cheats. But granted that it is true that these individuals, it could be that they didn't even cheat, see. It could be that you couldn't pay, brother. So they had to live and get a good life. But let's assume that they all cheated, each one after the other like this cheated. Does it warrant a necessary claim that therefore all women are cheats? Remember that all women includes your mother, your sister, your pastor's wife, your imam's wife, anybody you hold dear, the Virgin Mary. They are all included in this claim, all women. And even those who are not yet born, who will be born and will be girls and will grow up to become women. Take note of what I have said now, because in some few minutes, you see the implications of this kind of language that we describe as universal generalization. Okay, you see shortly. But now we are trying to show why all women are cheats cannot be supported absolutely. See that? Certainly by these several instances you've given. It only gives you good reason to assume, good reason to take this conclusion as highly likely. We are back on our slide here. See, highly probable. That is what is going on there. But you haven't proven that all women. Why? Because there are still exceptions to the set of all women that you haven't captured. So the more of such examples you can add, as you add Ajo, then you come and add Zainab, then you keep adding and adding. Now you have 117 women that have cheated that you can list. Yes, as you keep adding, you are increasing the degree of likelihood. So look on your screen, the more evidence you have that corroborates, the word is corroborate, support, agrees with the conclusion. Remember, the conclusion is already general. I showed you, okay? The more evidence you have like that, the higher the degree of confirmation. It's a matter of the degree of it, not that therefore you have proven it. Wrong language. You have increased the likelihood of that conclusion being what? True. Probability is never equal to 1. It's always a matter of degree under 1. All right. I mentioned that there are types of inductive argument. You should just know that because it could be a possible, MCQ question, multiple choice question, sampling, analogy, causal reasoning, enumerative induction. In this unit, you're doing enumerative induction. After this, my colleague will come and take you through causal reasoning. And then sampling and analogy, which is in unit 8, we will not delve into them in some detail. They are just straightforward and easy to access. You can do that. Okay. Now, so back to our examples of inductive argument, just for emphasis. Look at example 1. 80% of politicians are lawyers. Mr. Kofi is a politician, so he's a lawyer. We see why that is not a deductive matter. This is inductive because Mr. Kofi, even though politician, need not necessarily be a lawyer, given the nature of our premise. See, 20% of politicians aren't lawyers by my own evidence. So if I say I have a Mr. Kofi who is a politician, doesn't mean that he must be necessarily part of the 80. The same is happening with example 2. Example 3 captures our our enumerative induction that I have given. The person had 3 instances and concluded that women are cheats. We say, well, this is not a good number of evidence. If we did the unit that discusses samples, we'll see that this is a very, very relatively insufficient sample. Okay, but even if you gave us 100 million instances of women, you still couldn't have said that. Therefore, you have proven that all women are cheating, means all women. You didn't leave anybody else. Now that's a big, 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 big problem. So it will make your findings weak, and it may not apply after the research is done. Okay, it won't apply the data analysis and how you are making prescriptions. If all the sample you had were just these 3, and then based on that you are drawing this conclusion, you have a problem. It won't work. That's a problem. Okay, then look at 4. It's also inductive. 2 out of 5 women like rich men. This is still a generalization you see in a jiffy, just that you have left some members out. So you say 2 out of 5 women. The reference class is still women of all times, all places, born already, dead, yet to be born. You see, women. So it is a generalization. The only thing is you have done what? You've left some of the members out. So there are exceptions to your general set. And that is what is making it a statistical generalization, not a universal one like women are cheats, which doesn't exempt any woman from the reference. So are cheating, you attribute cheating to all women in this instance. It's a universal generalization. However, for this one, you only attribute cheating or liking rich men to what? Some aspect of the general set. So it is still general, example 4, and then example 3's conclusion is also general. However, for 1, look at the example 4 premise, 2 out of 5 women. I'm trying to show you 2 types of generalizations. 2 out of 5 women, look at that premise. That is what? A statistical generalization. And look at the conclusion there. Women like rich men. That nature of statement is what? A universal generalization. All right. But then the point we are making here is, if the premise were assumed to be true, would it still mean that all women like rich men? Not necessarily. So inductive. Same here. This one I just gave an example of it and used it. That's unit 5. So we are good to go. Now you are asked to practice activity 1.5, where you have some instances of what? Distinguishing deduction from induction. Take it to tutorial if you have some clarity you seek. We have able TAs, their tutorial times have been published at your announcement to every group site. I did the publication myself, they are there. So go there and look for tutorial times. I'm talking about your announcement to go through all the announcement. It has a wealth of information for you. You will see every tutor's link for every tutorial that is being conducted this semester at no fee. No TA should charge you for anything. None of our official TAs to the course does that. So if someone is asking you for money before they teach you, just in case, then the person is not an assigned tutor, and you should be wary about what that person may be teaching you. All right. So enumerative induction. When do we say a type of induction is enumerative? Look at the sampling one. You take a few, work on them, and then impose what you find about them to the whole. That's argument based on sampling. So when we take a little tiny drop of your blood and take it to the lab and investigate it and then make a statement about your health, it is something like sampling. We take a few, we find out about them, then we generalize about the whole. When you want to know whether Legon students like perching, and you ask 2 or 3 of them and give them questionnaires and take their input, and based on that, project about University of Ghana Legon students, you are doing sampling. Okay, so that is sampling. Then analogy, you compare 2 scenarios. So you see that two scenarios, 2 contexts, 2 persons, 2 whatever, okay, share the same common, relevant common features. They share the same. So when you look at person A, he has A, B, C, D in their blood. And then when you check person B, he also has A, B, C, D in his blood. So they have 4 common features. The features are relevant, not some accidental features that are not relevant to the matter under discussion. But for instance, they have these A, B, C, D in common. But however, person A has X in addition, okay, which you haven't yet detected in person B. Then by analogy, by comparison, you say that, oh, if this one, they have all these four in common, then the other one too that I see with this person, it is likely that this other person will have it. You haven't proven it because you might not have that X factor. That might be the only thing that distinguishes the two. But you have good reason to believe that then the other condition, the other person would also have the X. That is comparison and by analogy. So reasoning by analogy, you get that. However, for inductive reason, the other one that you engage with, my colleague, will be causal reasoning, cause and effect reasoning. This one gave, as soon as he came into the room, the light went off. So he he caused the light off. When I saw this grammar before going for my passport, I didn't get it. She caused up. You know, the way we do, because some people even believe that COVID is as a result of the wickedness of man, the sins of man, and all that. You see, how do we analyze the causes of things? Who caused them? Okay, who caused them? That is, we will look at who or what caused them. Okay, you look at various connotations of the word cause, how you sometimes you commit causal fallacies and what have you. So that is also another type of inductive reasoning. The enumerative induction, which is the focus of Unit 7, says what? It's listing evidence, enumerate to count. You see that? So that type of inductive reasoning where you count and count and count and keep adding to your specific particular evidences, like you see on the screen now, just so that it can increase the degree of likelihood of that general conclusion you are drawing. That pattern of reasoning is what is labeled as what? An enumerative induction. We have already said that no matter the number of evidences, premises here, you see, that you add to the given set of premises, no matter how many of them, it would still not mean that your general conclusion has been proven with certainty. So it is an induction. But which type? What is the model of inducing the conclusion? Oh, you induce that conclusion. How? By counting and counting and adding to it. So how do we arrive at claims like all metals expand when heated? We just keep testing metals. So we test the iron strip on the table there by applying some heat. It expanded when heated. Okay, then we tested we tested see on the screen now, gold, the gold chain. We put it inside fire. It expanded when the heat was applied. Then we tested the silver. Then we tested the bronze. So you see, I'm enumerating and I'm counting and I'm adding. Okay, brass, lead, zinc on your screen now, friends. Okay, then each one of them expanded when heated. So suppose initially we had only 4 premises, and we said all metals expand when heated. We keep searching. We added 5, 6, 7. Still, they were expanding when heating, when we heated those metals. Okay, that is giving us good reason to believe that it is highly probable that all metals expand when heated. But we haven't proven yet. You see how many times that has been repeated in this video so far? We haven't proven it. You don't want to say science has proven that, when all that we're saying is just a matter of science has confirmed the likelihood. Science has confirmed. When do you say science has confirmed? When you find even extra information that corroborates that. The methodology that is used is what we have called what? Enumerative induction. So another COVID patient has been discovered. So it means that it is the so-and-so virus or so-and-so whatever that causes vaccine, COVID-19. The more of them that you are counting, as you keep counting, you are doing enumerative induction. But it could be that we will find a counterfactual in a jiffy. Let's hold on with that for now. So see, the conclusion is all men are cheat. What are the premises? The individual particular statements. Look at the reference class. Specific persons, particular countable reference. I dated Amma. See, I have just dated Zainab. These are all particular statements. So we describe them as what? Verifiable statements. The reference class is finite. What I'm referring to can be counted. When I say reference class, I'm referring to what? The subject of the statement. We have every statement has the subject and the predicate. This should have been covered already in Unit 6. So you will know that the subject and the predicate. Every statement has a subject and a predicate. The subject, like for example, Kofi is a boy. The subject is Kofi. It's a boy, is a predicate. Kofi is specific, countable, finite. I can finish counting Kofi. Okay, so that is a particular statement. It's not a general statement. However, if I said all men are bullies, and you see that in a minute, men are bullies, that is referencing men. It's infinite. You won't finish counting men. Okay, because some are not even born. Some are now going to be born to start being toddlers, to go to class 1, go to class 2, go to JHS before they will become men. Think about that. But they are included in your statement. When you say men are this, politicians are that, metals are this, Ghanaians are that, and you keep speaking that way. You are speaking as if you are God. You are speaking in the eternity past, eternity future. That's how you are speaking. So we say it has an infinite reference class when you speak that way. Okay. Now, if you have a reference class, all women, we say that is not verifiable. That is what confirmable, because it is not a particular statement any longer. It has become a hypothetical statement. So the premises, as you see them here, are verifiable statements because they have finite reference class. They are directly testable. Okay, if I want to know if Amma cheated, I can set her up. I can put a CCTV camera in the room and see what she will do, and I'm able to test directly Amma. If I say women are cheats, can I put a CCTV camera on all women when some are not even yet born? Okay, so you can't directly test a general statement, friends, but you can indirectly test a general statement. So generalizations, which are called hypotheses, that's another label for general statement, especially when they are conclusions of what? Inductive argument, like we have them there. Then we say they are hypothetical, they are not conclusive. Conclusion, you see, is you are done with it, you don't get back to it. That happens normally in what? Deduction. But for induction, there are conclusions which are general. We already know the fault it has. So we say they are hypothetical. They are subject to further studies. Hyped up thesis. A thesis, a statement that has been blown out of proportion. Hype the event. See what you mean? So hypothesis. It means it is itself subject to further tests. So the claim all women are cheats, which we arrived at by independent particular search like this. By directly testing these premises, we arrived at a hypothetical statement like this. This hypothesis is itself still subject to further test. We will still be investigating it to find out if we could just find one particular woman who will not cheat. Then we can say, oh, our hypothesis didn't pass the test. It has failed. And then we will progress. All right. So premises are verifiable, whilst hypothesis or hypothetical statements are described as confirmable. How do you distinguish the two? Look at the reference class. Is the reference class finite? Countable? Can you finish counting what we are referencing? The subject? If you can, then it is what? A verifiable statement. Why? Because it was particular, which means you can directly test. Whilst the one that you won't be able to finish counting is what? A generalization. It may be statistical or universal. You saw that earlier, but it is a generalization anyways. So it is a confirmable statement, which also means you only test it indirectly. It's still testable, but it's tested indirectly, where you take a subset, find out about it, and then impose it, the view upon it to the whole set. You project. So it could be false, as we have seen. So we test it what? Indirectly. Well done. Now, so the two kinds of enumerative inductive reasoning is just where after your particular instances, look at this, after all those particular instances that you gave up there, see the evidence, gold, diamond, whatever, when you finish, you look at the conclusion, all metals. So this one, the conclusion you have drawn is a law like a universal hypothesis. You see that, where you don't leave any member out of the set. All metals expand when heated. From your several instances, you conclude that all metals expand when heated. That is a law-like hypothesis that is drawn from what? Your enumerative induction is one kind. Then the second kind is where, after listing all your particular instances of reference evidences, okay, all of them, you conclude that, so look at it, so most women are cheat. This is still a generalization, but most women, like I told you earlier, most women and all women are not the same. When I say all women, I have a stricter work to do, because even one woman who doesn't cheat will make my statement wrong. If I say, oh, all women are cheat, okay? Then if I get just one woman who is not a cheat, it will falsify my claim that all women are cheat. However, if I say most women are cheat, then it is a little bit more protected. If you found one or two women who are not cheat, I'll say, but I said most. I didn't say all. So I play safe, sort of. So it looks like statistical hypothesis like this, if you use this as a conclusion after your several particular instances like this, if you conclude, so most women are cheat, so most metals expand when heated, so most COVID patients die in 2 hours, whatever those things, then it is safer. The degree of truth is higher. Can you see that with statistical hypothesis? If you concluded with a statistical hypothesis, the degree of likelihood is higher than if you concluded with a universal hypothesis, also called the law-like hypothesis, you see. Then don't you think then that the scientists should have preferred statistical hypothesis because it has a higher degree of truth over and above universal hypothesis? Amazingly, no. The empirical scientist wants to make their theories more prone to falsification. So they prefer or they value universal hypothesis, law-like hypothesis. Like universal and law-like are synonyms of the same thing. Like a law, the law doesn't exempt anyone. The law is no respecter of persons. So we say it is like a law. All metals expand when heated. Then it is universal, means it applies to all. So we are saying the same thing when I say law-like hypothesis or universal hypothesis. And that's what you see in your textbook, okay? I'm saying that the scientists prefer such generalizations which makes no exception to the rule and are easy to make false. They prefer that. They value that. Compared to the one that is more likely to be true, like what? Statistical hypothesis. Why? Why is falsification or the principle of falsifiability valuable to the scientist? Let us see. Okay, so let's recap some things first quickly before we go to that. Now you have to progress with me as I am doing currently, because everything I'm telling you from slide 1 all the way here is a build-up. You have to build on it. So if you know observation statement, which is another name for what? Evidence, is another name for premises of an inductive argument, you will know that they are particular statements, you see, and you will then know that if it is a particular statement, it only means it has a finite countable reference class, which then means that they are directly testable. You see, that's the connection. They are connected. It's like you are building. So you can't jump ahead and come back and go. When you do that, you will struggle to understand something that is relatively easily accessible. It is the language and the many terms that are applying to the same thing that sometimes make critical thinking a little bit more demanding. But we will weather it together. So move with me. You cannot describe a particular statement as what? Confirmable. We have seen why. Now on this slide 10, then we can make sense of the claim confirmation is not proof. Inductive argument aim at confirming the given hypothesis. Now that is clear. While deductive argument aim at proving the given conclusion. This is from slide 1. It's just a summation to see where we have arrived at, where we have reached. The evidence of an inductive argument only confirms, but it does not prove the truth of the hypothesis. Again, you see me repeating that confirmation is not proof. And I suppose it will be so clear to you now. Now, the word hypothesis is the same as the conclusion of inductive arguments, whether that hypothesis was statistical or law-like. The same name for law-like, universal. So you see that these summations here should help you. Again, on this slide is a summation of what I've said. Verifiable versus confirmable statement. When do we say a statement is verifiable? Oh, that's what it says. If it has finite countable. The specific is a bit confusing for some of you. So you just say countable or finite reference class. And as you increase in depth, you can now talk specific without confusion. Okay. So particular statement there is therefore directly testable. Example, that man is a bully. That man, that man. Specific. See that man, you can finish counting that man. Finite. It is directly testable. It's a bully. You can directly test. How about the second one down there? Men are bullies. We have said that already. Men. You can't even have all of them to test via observation. Okay. So men are bullies is a general statement. So we would have described it as a hypothetical statement if it were the conclusion of an inductive argument. And we'll say we test it indirectly. And it's all because of what? It's infinite reference class. It's uncountable reference class. You can't finish counting the reference that we have here, men. So how do you determine if the attribute that is are bullies applies to all men? How do you determine that directly? You can't. You are not God. Okay. So general statements confirmable, particular statements verifiable. Again, you see everything I've said. These are all repetitive. The slides you see now to now cement it and make it more meaningful to you. Okay, so reference class, attribute class. That man is a reference class. The attribute class is it's a bully. Subject and predicate. The logician will say reference class and attribute class. So the attribute class is a predicate. And we have seen all of that. I can move on now. Universal or law-like. And you see why one is a universal generalization. Men are bullies. Whilst the second one is still a generalization, but a statistical one. Some men are bullies. I hope that some things are settling in now. So the reference class tells you whether a statement is general or particular, as well as the type of generalization. It tells you first whether the statement is general or particular. Then it goes further to even give you an information about whether it is a statistical generalization or a law-like universal generalization. Well done. Again, see, this is also repetitive. Is to cement it. Particular statements have finite reference class. They are directly testable and therefore useful as evidence. If I want to give a cogent evidence, let me just say that to you. Cogency is not captured in your textbook, so we are minded, but it adds to your knowledge of critical thinking. So let me just say that if an argument is a strong inductive argument, you see that where the evidence points to a higher number, so 80% of Ghanaians like pineapple. Nancy is a Ghanaian, therefore she likes pineapple. We said that that is a strong inductive argument, which means the strength is high. You have given us good reason to believe the probability of your conclusion. Okay, that is a strong inductive argument. You can never say that that is a valid inductive argument. Now you understand why. Now, if the argument is a strong inductive argument and the premises are all true, then we say it is a higher quality of an inductive argument. Which one is that? We describe it as a cogent inductive argument. That's all. Okay. So remember when we did validity of a deductive argument, we said if an argument is valid deductively and all the premises of that argument are true, they would say that valid deduction is what? A sound argument. Okay. So soundness is like a higher value. After the argument is valid deductively, then and its premises are true, then we'll even say, oh, this one is not just valid, oh, it is even sound in addition. The same applies to what? Inductive argument. After we say the premise, the argument is a strong induction and all of its premises are true, then we say, oh, it is even cogent. Okay. So just get that as a bonus. Let's come back to where we are now. So particular statements have a finite reference class. They are directly testable and therefore useful as evidence. When you use particular statements as evidence, now you understand particular, then you increase the degree of likelihood of the conclusion or the hypothesis you are drawing. It increases it because we or the person you are trying to convince can also directly test. It is not something that we have to conjure. We can directly test those premises. Okay. However, generalizations or general statements have infinite reference class. They are indirectly testable, and therefore you should use them as what? Hypothesis or hypothetical statement, conclusion. We describe them as what? Confirmable. I'm sure you know that now. So if I were setting 100 questions from here by now, from my unit 7, so that we will use it to examine all of you. By now, I would have had about 50 of my questions done out of the 100. And so you know how you will fare. You do very well in that unit. All right. We describe such statements as confirmable statement. Note, it is all about what? The reference class. Excellent. See some examples. Practice. Verifiable versus confirmable statement. You can see some of them in your page 191, depending on the text you are using. Okay. The disease is contagious. The disease. Is this verifiable or confirmable? The disease. Very good. I heard you in the spirit. It is verifiable because I'm referencing a countable class. The disease. Few Ghanaians. Is few Ghanaians general or particular? It is general. Very good. And because we said few, the class is Ghanaians of all times, all places. So that's a generalization. But I said few of that general set. So it's a statistical generalization. Well, whether statistical or universal, it is still what? Confirmable, because it's a generalization. Well done. The liquid in that bowl is poisonous. This is particular. So it's a verifiable statement. Okay. It's good as an evidential statement. Green tables are scarce these days. Some of you think of green tables as specific. It is not. That's why I said don't use specific, because it confuses some of you. Okay. So just think of it. If I were counting green tables, will I finish? Green tables of all times, all places. That is what the person says. A universal generalization. Good. So it is what? Confirmable. Coffee, particular statement. So verifiable. Now let's look at 6 and 7. All voters prefer a recount of ballots. That's question 6. And look at 7. All the voters interviewed said they will prefer. All the voters interviewed said. While 6 said all voters. I'm sure now you see the trick. So 6 is a universal generalization. Therefore, we say it's confirmable. Okay, it's a generalization. So we confirm it. While 7 is a particular statement. Yes, don't be deceived by the all. I said all the voters interviewed said they will. I have a specific group in mind. So it's a verifiable statement. No student registers unless forced. This is a universal statement. When you did your modus tollens and what have you, you saw universal negations. It's a universal statement. It's a law-like statement. Can you see that? Yeah. So it is a general statement saying if you're a student, then you will not register unless you are forced. Universal negation. The negation goes into the consequent tip for your modus ponens thing. Then the negation goes into the consequent. No student registers unless forced. If student, then not register unless forced. Okay, so take note of that. That is number 8. It is also confirmable. Then 9. None of the students in that class registered for their course. That is not a universal statement. In other words, it's not even a generalization at all. It is a particular statement. You can finish counting the reference. What I'm referring to is the students in that class. The class may have 3,000 students, but they are still the students in that class. I can count them. All right, and finish. Then 10. 80% of all retail stones are not real diamonds. Look at that. The reference is all retail stones, general. Okay, but 80% of that is what makes it a statistical generalization. If it's general, then it is what? Confirmable. Your textbook gave some example that in the past you find students struggling with. Say all those who contract the human equivalent of mad cow disease do so and so and so and so. All those. So when students see the those, they feel then because those, that, these are definite articles. So it looks like then it makes it a particular statement. No, listen to the language. You're not doing English, you're doing logic. All those who contract COVID-19 go to heaven. Let's speak that way. I want it to be short so you can focus on the reference. All those who contract one COVID-19 echo heaven. Many na COVID-19 I heaven. All those who contract. You see, I'm speaking the everyday tense. I'm speaking of everybody that contracted, including those who are yet to contract it in future. That is why it's a generalization. But if I said all those who contracted COVID-19 vaccine have been apprehended and whatever, given help or something like that. All those who contracted it. See how the past tense, has changed the statement from a generalization to a particular statement. Because the first one said, all those who get it. Whenever they get it, whoever gets it. It's a general statement, a law-like generalization. That is how you do the distinction. So when it is a law-like generalization, it has entered into the frame of what? Confirmability. You only need evidence to corroborate it, to at least increase its likelihood. Not that you have proven it. Very good. If you got that, then that is what is happening. See, degrees of confirmability. We saw earlier why statistical generalizations are easier to confirm than law-like ones. In other words, law-like hypotheses are easier to falsify than statistical hypotheses. Now you get it. Good. But the scientist prefers the one that you can easily make false, easier to falsify. So the scientist, empirical scientists, will prefer law-like hypothesis to what? Statistical hypothesis. See some examples on your screen. Maybe we read one or two. Example of statistical hypothesis. Some Americans are allergic to pineapples. 80% of all retail stones are not real diamonds. These are from your book. Most Christians worship on Sundays. Few Africans. Can you see why they are statistical? Yes. In example one, I'm referencing Americans. I just qualified it and made exceptions to the set. Americans of all times, all places. See that? 80% of all retail store, general. What type? Statistical. Good. Most Christians, I'm referencing Christians, but I qualify it with most. I make exceptions to the set. Few Africans approve of same-sex marriage. What's the reference? Africans of all places, all times. Dead, yet to be born. Always say that way in your head. And you see why it's a generalization. But then we qualify it and reduce it. So it is a statistical one. 2 out of every 10 what? Men. General set. What type? Statistical. Very good. How about the second set? Down the examples of law-like hypothesis. All voters prefer a recount of ballots. We've seen that. Voter biara epesi esan kan bio. Mo fe money chio ushiki and tell atwa. I can't say, how do you say it? I'm trying to do some guy here. Mo fe money chio ushiki le itoni achie kun. Especially those who don't win. All I've said is a repetition of what I said earlier in English. All those who vote always prefer a recount of the ballot, especially if they didn't win. It's a generalization. Speaking for all voters, including the voting that will go on in Ghana or Clinton's place or wherever, Trump or wherever, in the next 30 years. They are included. Generalization. No exception was made. So it's the law-like one, or which has also been called the universal one. Well done. Alcoholics are womanizers. So now you are able to distinguish statistical generalization from law-like generalization, and you are even able to tell us which one is more valuable to scientific study, empirically speaking, and then which ones are easier to confirm compared to the other, even where they are all what? Generalizations. Now note, statistical hypotheses are easier to confirm, therefore less valuable to the scientist. I've explained that. That one is easy to confirm. The scientist is not looking for what he or she can easily confirm. We'll get that there in a minute. Why does the scientist rather prefer statements that can easily be made false. We'll see. Okay, degrees of confirmability again. Statistical hypotheses are easier to confirm, blah, blah, blah. That makes statistical hypotheses less valuable to the empirical scientists. How about law like? They are easier to falsify. Therefore, they are more valuable to the scientist. And see, it is a surprise. So you see, it comes with an exclamation sign. Now let's see why. Finally, we get to why falsifiability is valuable to the empirical scientist. Listen attentively, because there is a logic behind scientific study. The deductive nomological method. Don't worry your head over that big word. That is for the methodology of natural science, okay? Just listen to the thinking behind it. That is why you are here. When you finish, you continue with your specific discipline. So we will not teach you as if you are just here to do philosophy, okay? Now listen, economists, sociologists, psychologists, political scientists, every one of us who believe we are gathering data, empirical studies, observe through the senses and gather rule laws and then work with that law. Remember unit 5, empirical laws. The same also with what? Natural scientists, those who are studying the physical world, not human science, where they are studying how human beings are behaving with each other. But they are all empirical studies. Okay. What every empirical scientist is doing, so focus now on the physical sciences, it's easier to get the point. They are trying to investigate the world, to find what is true about the world with certainty. Certainty. No human being created the world. The world was created. And we are here trying to live in a world that we didn't create. So we are constantly, we here referring to the empirical scientists, is trying to discover. The thing is covered. You are trying to uncover it. You are trying to discover what is really there in the world. Not what you thought is there. Like you thought the earth was in the center of the universe, geocentric view. For many years. That was false. How did we know it was false? When we discovered the heliocentric view, that the sun rather is in the center of the universe. Can you imagine the whole world deceived for years? It was empirical study. We thought sickle cell anemic patients will not go beyond a certain number of years, 18 years or so in the past. That was what had been discovered. How was it discovered? Several instances of sickle cell patients that passed, apologies, before that age. So then the empirical scientists then will say, so you will not generate a law. All sickle cell patients will not go beyond a certain age. Okay? But it was just a hypothetical statement, which meant further study and research may corroborate it, which is not too good a news for us, or negate it, falsify it. Now, if you keep looking for evidence that supports, that corroborates what you know as a hypothetical statement, it increases the degree of likelihood. Look at the second point on my screen. But it doesn't give you, the scientist, the empirical scientist, any joy, because it may turn out to be false. You're having several metals that are expanding when heated. Your hypothesis is what? All metals expand when heated. That is what you have discovered in all your many years of practice. You see that when you test iron, it expands. When you test gold, it expands. So you come to a certain hypothetical finding that what? All metals expand when heated. But remember, we said that one is itself subject to further tests, because the potential that you will find a certain metal that will not expand when heated is still there. So the scientist has not achieved his set aim or goal, which is what? Certainty. We don't care how many metals keep expanding when heated. It still doesn't prove, now you understand, that all metals expand when heated. So what the scientist is looking for is certainty about the physical world out there, the empirical world out there. Therefore, if science or in her research, she discovers a specific metal that will not expand when heated, voila, that is joy. That is good news. Why? He will come and say, oh, Asumwa, not all metals expand when heated. not knowing not all metals expand when heated. That one, the scientist will know with what? Certainty. He will be very 100% certain that what? Not all metals expand when heated. Okay, then we are inspired to look for those such metals again. The point is, certainty will come at last. When we rather discover a counterfactual, a negative fact, a fact that doesn't corroborate what we knew all the time, we will then know with certainty. Then we will know that, oh, as just means not knowing. It's gone. Let the guns feel at home a little too. Okay, so you then know that not all sickle cell patients, anemic patients, really die at 80 years. Then science has progressed. Now we know something with certainty. That is the method of the scientist. So instead of looking for instances in the world that gives you fans, gives the theory fans, in other words, support it, corroborate it, that one is not too good a news. Why? Because when you finish doing the party of celebration, oh, we have found more metals that expand when heated. As soon as you step out, you could find a metal out there which will not expand when heated. Then what is the essence of your party? It will come and negate all the hundreds of years of research, which gave you several corroborative evidence. Can you see that? So the point of desiring and valuing falsifiable statements is because it rather gears the empirical scientists towards certainty about their hypothetical statement. That is why empirical studies are not like dogma. Doctrines don't want anyone to contravene them. But scientific study is not like that. You shouldn't have a posture that doesn't want your theory to be falsified. Note that if someone even indicates, I think that I have a cure for HIV, for example, or I have a cure. I didn't say something to manage it. A cure for a certain X or Y disease, or I can investigate this. I have a certain or alternative view about this supposed hundreds years of finding that you people have in scientific. When someone makes that proposal, people should not be in a hurry to rubbish it. That you buy something that we have tested and tested and tested for many years. Who are you to come and say that it is not wrong? That you are not holding a dogma. You didn't create the world. You have to get in that different perspective, because it may be the counterfactual we are looking for to attain certainty of certain truths in scientific study. Okay, and Copernicus and his friends who were pointing that no, I don't think the Earth is in the center of the universe. So look at the angle of this. Look at this. When they were pointing it out, some of them were killed for that because people had built doctrines around that false claim that the Earth was in the center of the universe. So the idea of protecting theories, making statements that will necessarily be true all the time, regardless of the findings out there, is not a scientific posture. That is what we want all our empirical science students amongst you to have in mind, that the aim is not to have doctrines in an academic world. You can do that in faith and protect our beliefs and our, but for empirical study, your statements must be open to what? Tests. There comes the next concept into it. Testability. It must be scientific in nature. That means when you say it, it should give us reason to go and find out. If we find out and what you said applies to what is in the world there, then what you said is true. If we go and it doesn't apply, what you said is false. But that is what makes a statement a scientific one. A statement that can be false, has the ability to be false. A statement that is what? Falsifiable, able to be false. Good. Let's read what we see on the screen now. Why falsifiability is valuable to the empirical scientist. When a theory is falsified, then the empirical scientist can be certain that it is not true. Whoa, yes, I explained that. But when a theory is confirmed and you find more evidence that supports it, it only means there is currently evidence that corroborates the likelihood of the theory being true. You see that you are not certain of it being true, but you can be certain of it being false by just finding one counterfactual. Third bullet, but the empirical scientist cannot be certain that a confirmed theory is certainly true, because there's always the possibility that we may encounter what? A counterfactual. Counter means opposite, an opposite fact, a counterfactual. Last bullet, so what? What's the implication? So law-like generalizations are more valuable. Next is statistical generalization. Then the third is what? Verifiable statement in the degree of what? Value. Law-like first, statistical, then what? Verifiable. Because the law-like one is the easier to make false, easier to falsify. Next to that will be the statistical generalization before a verifiable statement. I talked about a scientific statement being testable or falsifiable in my explanation earlier. Now that is what is ongoing here. So to be scientific is to be capable of being true or false, empirically speaking. That is to say, to be testable. So we test it to ascertain the very point whether it's actually true or actually false. Okay. If the statement is not open to being either true or false, then there is no need testing, because the test will still make it true if it is necessarily true, regardless of what the evidence out there says after our search. Then there's no point going to search. It is already true. We don't want such statements, protected statements like that, which are always true. Okay. It makes sense to research only if what we found earlier could turn out to be false. So take note. Uncertainty, when we are not certain, is a virtue in science. It's valuable. Virtue means we cherish the fact that our theories are not certainty. Okay, that is why it makes sense to research. So science thrives on research. You searched, then you go back to search again. You research and research and research. Why? Because the 9 planets could be false. It could be 8. Because the heliocentric view may come up to overtake the supposed geocentric view that we have held on to. And we can go on and on and on. So research is meaningful only because scientific theories are uncertain. So there is no shame about it. The scientist, proper empirical scientist, is happy when his supposed theory that the heart cannot live. I mean, if someone's heart stops pumping, it cannot be revived. So hearts that have stopped pumping cannot be revived. Then one day, another scientist, as he's working, sees that no, if it is within the first 5 minutes, we can do X, Y, or Z, and that heart can be revived and pump again. Is that not a joyful news? Why should I be protective of my theory? Don't try that one. You don't need to try, because as for heart, when they stop, they don't get revived. What is the point? How does it? Are you the one who created the world? Are you the one who created the heart? Let the person who is exploring have enough room to do the research and find out. For all you know, we may be able to revive the heart. Is that not happening now? It is. Good news. So therefore, a statement that cannot be false is a pseudo-scientific statement. Pseudo means pretending to be something. So there are pseudo friends. Pseudo is spelled with a P for those who may be special students and have to hear me. Yeah, the reason why some of the slides I read them out. Okay. Pseudo is as if you are writing psycho, PS, and then you add the rest. So pseudo-scientific statement is a statement that is pretending to be scientific, pretending to be testable, pretending to be falsifiable. And yet, if you look at it closely as a critical mind, you can tell that that statement cannot be false. If it cannot be false, then it's not scientific. There's no need to go and test it. It means it is not testable. Some of such statements are what? A statement like, tomorrow it will rain or it will not rain. If I tell you tomorrow it will rain or it will not rain, that is necessarily true, even if tomorrow never comes. Let me show you. Suppose you want to harvest your dry crops. You have a very big farm of maize, plantations of, we say that, yeah, of maize. So maize farms, many of them. But you can do the harvesting, mechanical harvesting or technological harvesting today in 3 hours with your machines. However, you have to also start digging another land. So you are not sure if you should use this short time you have to harvest or to do the new planting. That is, if you know for sure whether tomorrow it will rain, then you will rather harvest what you have and let it rain to make the land fertile for your next planting. But if it doesn't rain tomorrow, then you will lose out on this. So what is the point? You want to know with what? Certainty. In other words, you want to know, even if not with certainty, whether tomorrow it will rain or not. So you call your meteorologist friend who has studied all the weather conditions and what have you, and expect and say, my dear, say tomorrow will it rain or not? Because you need that information for something. Then the expert tells you, oh, tomorrow it will rain or it will not rain. Will you be happy with that? What did they say? But that one you knew it already. You knew that tomorrow it will rain or it will not rain. You want information that is testable. So if he tells you tomorrow it will rain or it will not rain, he gave you a tautologous statement. That is necessarily true always. Even if tomorrow doesn't come, it is already true that tomorrow it will rain or it will not rain. He should tell you that tomorrow it will rain. If tomorrow comes and it doesn't rain, you can tell him that what he said is false. Friends, he should tell you tomorrow it will not rain. You can test that. All you have to do is wait till tomorrow comes. Simple. Whatever happens tomorrow will either confirm what he said or negate it. So then, when he says it will rain tomorrow, that's scientific. It's testable. If he says it will not rain tomorrow, that is scientific. It is testable. But if he tells you tomorrow it will rain or it will not rain, that's not scientific. It's a pseudo-scientific statement. Tell him that, but that is already true. You are a panelist, then they ask you the match that Ghana and Nigeria are going to play. Will Ghana win or not win? And the panelist say, oh, look at the conditions and Ghana play. Ghana will either win or not win. Then they say, depending on it, Ghana will either win or not win. But that one, we knew it before. That's why those who are going to bet are anxious. They don't know what to do. If we knew for certain that Ghana will win, we'll make a decision. If we know that Ghana will not win, we'll make a decision. But the thing is, we know that Ghana will either win or not win. That's why we are asking you for information. You are the scientists. Give us something that we can test. So tell us, Ghana will win over Nigeria. Go and bet. Then we'll go and bet. And if we go and Ghana doesn't, we'll come and beat you up and take our money back. See that? Or tell us Nigeria will win. So that the Ghanaians will put their money down and just go and enjoy the thrills of the whatever of the moment. The point is, don't give us statements or claims that are protected in the name of science. If you do that, we will point it out to you. That is a pseudo-scientific statement. So pseudo-scientific statements are tautologous. They are necessarily true, regardless. They cannot be false. And therefore, they are not testable or what valuable to the scientists. Can you see that? Excellent. Empirical content, degrees of falsifiability, and predictive power. These big words I put up there are all talking about the reference class that I mentioned earlier. So if you have a general statement, the universal one, it will have more empirical content. Empirical content just means what is contained in the reference. It will have more empirical content than a statistical generalization. Now, those are clear to you. And statistical generalization will also have more empirical content than the verifiable statement. Now you see what is happening. Okay, so if I say all women are cheat, that has more empirical content than saying some women are cheat. And some women are cheat will also have more empirical content than saying that woman is a cheat. It's as simple as that. Okay. Now the degrees of falsifiability follows the same pattern. It is the reference class still. So all women are cheat is easier to falsify than some women are cheat. And the statement some women are cheat, which is a statistical generalization, is also easier to falsify than what? That woman is a cheat. Now, predictive power, the power to predict. If I know a lot, if I know about all women, you see, I can predict higher. I'll have a higher power of prophetic unction, a higher predictive power than if I know about some women. or that woman. Okay. If all I know is something about that specific woman, how much can I predict about the set of women? I don't have much to say. All I know will be the experience I have with that particular woman. But if I have a theory that speaks about all metals, all water, all electricity, then I'm able to have a higher power of predicting. You see that? So if water is flowing in the drain, or it has rained and the place is flooded, I know that water is a good conductor of electricity. Okay, then I see that the wire from the electric cable, live electric cable, has fallen into that rainwater where the sister has parked her car in the rain. She's stuck in the car, but now she wants to sit down and waddle her way through the water into her room. I'm in my room upstairs, and I see that the electric cable has fallen into that flooded water there, and the sister is getting out of her car. You see how I will shout and say, "Hey, hey, hey, sister, hey, hold on, what? Why am I going to say that? Is it the Holy Spirit revealing something to me? Not exactly so. I am able to predict what will happen because I know something about all water, all and all electricity. So I can predict what will happen if she puts her leg in that water out of the car. The water is already electrocuted. Water is a good conductor, water of all kinds. So as soon as the sister is about taking her leg out, I will shout and predict what will happen. Sister will be obituary if she doesn't take her out. Is it Holy Ghost direction? No, it's the power to predict. The power to predict when the sister's trouble will begin. Trouble because she's a teenage pregnancy. Teenage pregnancy. So from 9 months, when the baby drops, boom, diaper, pampers, weighing, you are able to predict that in 9 months' time, yeah, you won't have all the time like this. So why are you able to say that? Because you know something about all women and their pregnancies. Remember, it could be that this sister's trouble will start earlier, 7 months, because the child can be premature, or it can even start later. But the generalization, the theories that we arrive at help us to predict. So if it's a general claim, you have a higher predictive power than if it is a statistical. Okay, let me clarify that. If it is a universal generalization, you have a higher predictive power than if it is what? A statistical generalization. And that will also have a higher predictive power than if it is what? A particular statement. As for the pseudo-scientific one, it has no empirical content. Look on your screen now. It has no empirical content. It has no predictive power, and it is not falsifiable. So we don't even include it as a scientific statement. The same with what you see on the screen. All these have said they are repetitive. A valuable empirical information must be falsifiable to be scientific. That's another way of saying it must be testable to be scientific. A statement that is not falsifiable cannot be a verifiable or confirmable statement. A statement that is absolutely true, friends, has no empirical content. So it is pseudo-scientific. I hope you are breathing. We'll finish soon. Compare degrees of falsifiability, empirical content, predictive power, scientific value. Now you know all those concepts. Try. Look at example 1. If I asked you to compare which of the following has the highest predictive power, just look at what? The reference class. So you see that in the 3 statements on the screen, the Earth's orbit around the sun is elliptical. All the planets that were discovered by Kepler before 1620 AD have elliptical orbits. And then the last one, all planets have elliptical orbits. Which one has a higher reference class? 3. Very good. All planets. The second one said all the planets. All planets and all the planets are not the same. Now you know how to speak. So 2, all the planets is a particular statement. Look at 1, the Earth. The Earth, that is also a particular statement. But 1 and 2, though both of them are particular statement, therefore verifiable, their empirical contents are not the same. One has more empirical content than the other. Can you see that? All the planets. We currently have 8 of them, we are told, or 9 or 10. Confusion. Okay, so there are at least more than 5 when I say all the planets. Okay, but if I say the Earth, I'm referring to only one planet, so the empirical content there is less. As for the example 3, it is the boss. It is the boss. Why? It says all planets have elliptical orbit. So the scientists will value that over and above. There's no statistical generalization in this. If there were a statistical generalization, we would have taken that. Like if we said 80% of planets have elliptical orbit, that would have been a statistical generalization. And it would have been next to the third one. Okay. So for now, let's work with what is on the screen. Compare the degree of falsifiability, empirical content, predictive power, scientific value. Which one has more scientific value? Number 3, because it has the highest reference class. Which one has the highest predictive power? Number 3. Which one has the highest empirical content? Number 3. Which one is the easiest to falsify? Number 3. I could have turned it and said, which one is the most difficult to falsify? It would have been number 1. You see, those are the intricacies that you should practice. An example, try. Heavy smokers are prone to cancer. Most heavy smokers are prone to cancer. Look on the screen. Giving you a typical examinable question. Look on the screen. That heavy smoker is prone to cancer. And then D, either that heavy smoker is prone to cancer or he's not. This can be a question I will ask. It can be. I didn't say it is, but it can. Now, if I asked you that with reference to the giving options up there, answer the following question. Then question 1 says, which of them, these 4 up there, has the least predictive power, the smallest predictive power? Which one would you choose? The one that has the highest is the all. So which one has the least predictive power? Over to you, Julati. Note that D, which is either that heavy smoker is prone to cancer or he is not. That is not even a scientific statement. It is a pseudo-scientific statement. It is a statement or its negation. Okay, so it is not even scientific. It is not testable. It has no empirical content. Take note. I'm giving you some clues to help your revision. It is not falsifiable. So that alone should give you some promptings. Which has the most empirical content? You know, right up there. Which is or are pseudo-scientific? You know, D. Which is easiest to falsify? You know, A. Okay. Which is or directly testable? You know, which one is directly testable? C. Which would you call verifiable? It will be C. You see that? Which is absolutely true regardless. That's D. Which is tautologous and therefore empty of empirical content? D. Which would you call hypothetical or confirmable? Take note, hypothetical, hypothesis, or confirmable. Which of them? There are 2, A and B. Can you see that? Because both of them are generalizations. The first one, though, is universal. The second one is statistical. But they are both hypothetical or confirmable. Then 10, which would you use as evidence or data or observation statement? I would do C. Excuse me, for the reasons stated. Now you can breathe. We are so done. It's the end of lecture 6, which engage with unit 7, because we didn't do unit 4. So we are ahead. The lecture is 6, the unit is 7. The next topic you should expect from my colleague will be on unit 9, on causal reasoning, which you should be reading ahead. The textbook is already with you. Okay, he will put, and then you will have slides from your regular lecture for your group. Whilst these ones that we are preparing and putting together will constitute the examination dossier. Okay, so you can never have any excuses. Now I said, take note, you won't do unit 8. If you study you use all your time to study unit 8, and you tell us unit 8 questions card didn't come, nobody told you that you'll be examined on that. All right, then I'm just for, this is a house rules from the coordinator to you. Interim assessment preparation. This content goes to all the groups, so there is no partiality anywhere. It goes to all of you. This is your content that you should be engaging in tandem with the required tests as preparation for exam. You study every content that your lecturer has given you. But if you want to make sure that you have covered all that you have to cover in terms of lecture, for this specific unit 7, this is the examinable content. The unit 6 examinable content is the one that is in the examination dossier. The unit supervisor will put it there. If you want the examinable content, in other words, the lecture, okay, for unit 9, it will come also with the code. So I'll put all into a folder in your resource tool on all the individual group sites for main campus. Make that your own, make that effort. Don't be blaming people for things all over the place. Make it an effort to go to the course site yourself and read information, and then make use of the content there as guided by the constant in the whole show, which is what your textbook, and you'll do fine. What unit you cover for the interim assessment? Repeating it again. Unit 1, 2, 3, 5, 6, and 7. You will see that so far you haven't done any direct exercises on the specific units. For some of the groups, your continuous assessment exercise is written. We want you to write, construct. So you are writing 400 to 600 words, kind of write-ups, then discussion questions and what have you, so that you can really bring out your critical thinking skills. And it's off-site and you will have enough time to do that. Exam time, though, for both interim assessment 30% and final exam 50%, you won't have all the time to be writing essays. So we won't be able to examine you directly on your ability to construct, create, argue, reason, what have you. But then we'll test that from how you are able to pick responses after we have given you those narrations. So you have some multiple choice questions, some short answers that are not lengthy to take too much time when you are typing. So 1 hour, you will be able to answer those questions, covering all these units. You should make that your priority. And then for exam, the final exam, which is 50, we will do unit 6, 7, 9, and 10. All what I'm telling is already in your course outline, also at overview of your course site. If you have never been there, go there, friends, and read it. I want to wish you well. We pray for you. You should study and do your bit, and God will do his also. Have a wonderful, blessed week and semester. I wish you well. My name is Dr. Nancy Miles. Bye for Jimfi. Take care.